Okay, so now we're moving to take another step in our journey here on our mass or converting now between one substance going to a different substance. So again, as I said last time with mole, that was just the center, how we get from one substance to the other. This is always going to be, again, different substances. Now, when you do mass, you're always going to do, I should have wrote substance, so I'm going to do it in a different color for no particular reason, okay? Always, when you're going from one substance to another, you use mole. Yes, I hope you're yelling it at home. Coefficients, okay? Mole, coefficients, okay? So you're always going to use that when you have any type of conversion between mass to mole. You have a different substance, or maybe moles of one substance to the mass of another substance, or from mass of one substance to another mass of another substance. So there are quite a different amount of variations that we can do. And if you look at your mole map, again, we're ignoring the volumes and we're just going down the center here. So you could start with mass of substance 1 and then go to mole of substance 2, or you can go all the way to mass of that substance. So there's 1, 2 steps if you just go to moles of that substance. Then there's 1, 2, 3 if you go to mass of that substance. Or we could even start with moles of one substance and go to moles of the other. That's just that one step like we just learned the last lesson. Or we could want to go to mass of the other substance. So it's mole to mass. That's 2 steps. So it could be 2 to 3. Well, it could be 1, like we did mole, to 2 or 3 steps. So just pay attention to all that. Now, remember mole, coefficients, and then do not start putting coefficients everywhere else. When we convert from mass to mole or mole to mass, either way, it's the same thing. It's just where they end up in the conversions. We're going to use the periodic table, and we've done this before. So don't try to redo what we've learned. It's always per 1 mole when you use the periodic table. So it's 1 for the mole when you're going to grams, okay? So grams per mole is the unit that we get off the periodic table. So nitrogen is 14.01 grams per mole. Remember, we always go to 4 sig figs just because I said so, okay? So 4 sig figs is what I asked for. It's not necessarily what you may need every time in the real world, but that's what I'm asking for so it doesn't limit your sig figs. All right, so our first problem here, Sammy, scientist has been given the job of producing ammonia. To be used in fertilizer, ammonia is synthesized or made by combining nitrogen and oxygen. Calculate how many moles of ammonia will be made from 1.3 moles of hydrogen reacting with excess nitrogen. Remember, that means absolutely, hey, I got it easy street, nothing to worry about. I'm not worrying about the other reactant. How about calculating the grams of ammonia too? So we're going to go through a few steps, and it's going to take a little bit of this paper here. We're just going to start slowly. Every problem, what have I asked you to do? I'm saying, hey, what are our givens? Well, I can find them fairly quickly here, okay? I'm given that there are 1.30 moles of, and that's hydrogen. Remember, hydrogen, when it's written in the equation, is H2 because it's a diatomic or Hoberfinkel or Brinkelhoff of one of the 7 and the 7. When you start with element 7, make the 7 for some of you guys who learned it that way. And then what is my question or questions, okay? In this case, I'm asked to calculate how many moles of ammonia. That's one of my questions, okay? So question 1 here, and I know there's 2 questions. That's why I'm going to label them as 1 and then 2. So my question is moles of ammonia, and it does say here ammonia is NH3, and that is a weak base like we've learned before. Question number 2, if we read on, how about calculating the grams of ammonia too? So we're going to go to grams of ammonia also. Now, what I'm doing really is taking you through a problem, but doing it in 2 steps. And then I'm going to show you how we can just do it, get it done, okay? Usually I like that method best, but just to start out with, let's do it kind of slow. When you go from mole to gram or gram to mole, we already talked about it. It's always 1 for the mole and then whatever that mass is, and then we figure it out, okay? So let's do the first thing. We need to write the balanced equation. I probably should be looking at the equation up there, but we'll go back and forth a little bit. So what does it say? We're producing ammonia, all right? So again, let's put in our yield sign. Product means it goes over here on the right side. So we have ammonia. I leave a blank just in case for the coefficient if I want. What does it say is going to react? It's synthesized. So this is a synthesis reaction. So what does that tell me? That product is my only product. So I'm done after I do this. It's combining nitrogen and hydrogen. So we're going to take, first reactant is nitrogen. Again, Hoberfinkel, okay, or diatomic, or Brinkelhoff, or the 7 and the 7. And that is then separated. And then we have hydrogen that we're going to find with it, H2. Now, later on as we go, we put the phases of matter. This time we don't have to worry about it, okay? Now, we do need a balance. So I can see right away what sticks out to me is this 3 for the hydrogen and 2 for the hydrogen here. That means I'm going to find that common denominator to balance it, which is 6. So 2 times 3 is 6 hydrogens, and 2 times 3 is 6 hydrogens. So now my hydrogens are balanced. But what happened? My nitrogen, I have 2. So here, I have 2. So that is a 1. I leave it blank. Remember, you don't fill in those coefficients. So my coefficients are 1, 3, 2. So that's my mole ratio, 1 to 3 to 2. Now, here's what we're going to do. The first thing, we're going to start with our given. Our given is 1.3 moles of hydrogen. So let's go ahead and draw that down here. We're going to use our conversion here. And that's moles of hydrogen was what we were given to start with. Remember, a lot of times what I told you I like to do is go here and write it on here. I start with 1.3 moles on the equation. And what's my question? My first question was, or is, moles of ammonia, all right? And that's what I'm being asked to do here first, okay? Convert the substance to what we want using the conversions, okay? So we're going to go to what? It asked me moles of ammonia, and then I'm going to do later grams, okay? So this is question 1. This is question 2. So let's just take care of question 1 first, all right? And so we're going to take moles of H2 down here because we don't want it. We want it to cancel to 1, and we're going to go to grams, okay? If you are using your mole map, which a lot of people like, I'm starting at moles. Whoops, I'm not going to grams. What am I doing? See? Good thing I checked. So when you look here, you're like, wait a second. Let me show you why I realized that right away, which was silly. And I'm going to erase everything else here too for a second because now I realize what I did. If I start at moles of a substance, I'm not going backwards, guys. I'm not, because I want to know between two substances. So I want to cross the bridge. So I'm going for mole, and I have to get the moles first, okay? So I am going for moles of ammonia when I'm starting with moles of hydrogen, okay? So we're going from moles of hydrogen to moles of ammonia. So that's just mole. So what did I do wrong? I went back to grams. A lot of people do that, so I'm actually glad maybe I did do that so you could see, no, I don't want to go backwards. So I'm asking for moles of ammonia. So I am, and again, this is the only place, I'm going to emphasize this because I didn't last time. Whoa, explosion of things. When I do mole coefficients, I must be changing substances, okay? When I don't change substances, you cannot use coefficients, okay? So when we do gram, mole, gram, that's not changing substances ever. So right here is the only place, the mole bridge is the only place, your toll bridge, you pay with the coefficients to get across. So the 2 goes here with the ammonia, and then my 3 comes down here with my hydrogen. Be careful, hydrogen and nitrogen get confused quite often. Now I'm going to pick up my calculator and do the math, all right? So when I do this, what is going to be the case? Sorry, I can't find my calculator. It was buried. There we go. Okay. We are going to start with our given. You always start with the first number in the front here that you were given, 1.30. You can type in the 0. You don't have to. You know that's a sig fig later. Times 2, because it's on top, you multiply. And if it's on bottom, you're going to divide. Okay. So that's basically what it's saying is 2/3, right? To multiply by 2 and then divide by 3. I copy down most of my answer. 666 repeating, okay? And now I want to go to sig figs. Remember, PNC, if you haven't learned it that way, that means, is there a decimal point? There is a decimal point, check. And as long as you check, you're going to count it at the end. This is count as a sig fig. So what are we going to do? Is there numbers before the 0? Well, yes, there are. Okay, so check, check, check. We're going to count it. So that 0 gets counted. So PNC is for your zeros. So we have 3 sig figs here. These are counting numbers. You'll never let it limit. So it's just 3. Goes to that given. So the 6 rounds that 6 to a 7. So our answer here for the moles of ammonia are 0.867 moles of ammonia. Please label not only the unit, but the substance, and circle your answers because we need to know what you found. That's one answer. Now I need to go to grams. So what I'm going to do is I'm not going to go backwards again. Remember that. So I'm going to start with moles. I'm already here on the other side of the bridge, so I just have to go from moles of the ammonia to mass of the ammonia. We're with the same substance here. So we're just doing a molar mass problem or a mole to mass problem. And so I'm just going to flip the page over here and do that, okay? So what was our answer from before? It was 0.867. So we're starting with our new given that we just found. So we found the moles of ammonia, or you could start over and do the whole thing again, which does not make sense. So let's use what we got. All right, so now we're going from moles of ammonia. Now we're not changing substances here. We're just going to grams. So we just want the mass. So this is just gram, mole, mole, gram. This is what we have done already in the past. It is 1 for the mole. Do not start using coefficients. It's only coefficients when you have mole, mole. We don't have mole, mole. We only have 1, okay? So 1, and then here comes a little bit of the work. We got to add up the molar mass. Now I like showing your work so I could see if there was an error. I can give you propagation points. Propagation in any of these things means you worked forward correctly. So I will penalize you for your 1 mistake, and then we will go forward. Now I'm just filling in the molar masses because most of us know that, but I should go back and just say again, nitrogen, 4 sig figs, 14.006, that rounds to 14.01. And then hydrogen, it is going to be 4 sig figs, so that 7 is going to get rounded by the 9, that's 1.008. Okay, so you'll get used to these numbers. Hopefully you already are. So we just need to make this molar mass, or divide it, or multiply it out, times 3 is 3.026. Now we're paying attention to decimal places when we add. So there's 3 here and 2 here, so we're just going to give it to 2 decimal places. So add that to 14.01, and that is 17.03. I do not want the 4, does not round it. I don't want it because I only want 2 decimal places. So when I go now, I've got the problem. I just need to multiply because it's on top. So I start with my given, 0.867 times 17.03. And that's going to give me, I'm going to write more of the number to begin with, the answer. And then I'm going to go to sig figs. So going sig figs, again, we started with 3 because that's what we had before. Remember, 4 was what I told you had to go to for the molar masses, so it's not going to limit it as often. And then 1 is a counting number. So again, we're going to that 3, the given a value, which is usually what happens. That 6 does round that to 14.7 is now 8. And that is grams of ammonia. So make sure you get the right unit and the right substance, circle your answer, and give me the perfect answer. All right, so now what we're going to do is we're going to do it all at once. Actually, what I'm going to do is I'm going to stop this video here so you can quit this one and take maybe a little break and come back and see how to do it all at once. So we'll have a second video.